Kia ora Year 11 and 12. This is the first part of question 1 of last year's algebra paper. Now, unlike most of the other papers, it gets up to an excellence question in part C, so this is all not going to be completely straightforward. Alright, the first one is to simplify this expression, leaving our answer with positive indices. So we're going to start by working with that negative power. So 3b over c squared to the power of negative 4 equals c squared over 3b to the power of 4. So I'm going to do this in lots of wee steps. You might want to leave a couple out. So the numerator is going to be c to the power of 8. The denominator is going to be 3 to the power of 4 times b to the power of 4. So most of you will leave that line out, but if you're having trouble remembering what's going on, remember it's this number to the power of 4, not times 4. So that leaves us with our final answer, which is c to the power of 8 over 81 b to the power of 4. Okay, on to the next one. Write x squared minus 8x plus 10 in this form here. This is another way of asking you to complete the square. So we look at the first two terms and we take half of this one. And that gives me x minus 4 squared. Now let's think about what we've done here. We've managed to get x minus 4 times x minus 4. That's going to give me the minus 8, but I've accidentally added in a plus 16. Okay, so if I expand out that x minus 4 squared, I'm going to get x squared minus 8x plus 16. Right? I don't want to have the plus 16. I'm going to take that out to make things how they started off. Okay, so my final answer is x minus 4 squared minus 6. Alright, this question is a merit question. It's a little bit different. It's quite cool. So show that the solutions of this equation, the quadratic, are 4 times the solutions of this equation. Now there are a few different ways to do this, but probably the most straightforward is just to factorize this and find the solutions, and then factorize this and find those solutions. So let's start with the easier of the two, because that will also give us a clue for the second one. So we've got x squared plus x minus 56 is 0. Just having a look, we want two numbers that times to give us 56. We're going to have x here and x here. We want to have a plus 1, so we're going to put the big number here, plus 8 minus 7. So let's have a quick look at that and check if that works. X squared plus 8x minus 7x, so that works, times plus negative 56. That gives me two solutions. X is negative 8 or x is equal to 7. Now we're asked to show that the solutions here are 4 times the solutions of this one. So what we're looking for now is to have x equals negative 2 and x equals 7 over 4. So we can have that in the back of our mind. We'll go up to the second equation, and we've got a really big clue of how to factorize it. Let's see. Well, we know that if one of the solutions is meant to be x plus 2, one of the solutions is x equals negative 2, so the factor is x plus 2. So let's make this all work. So we're going to have 4x squared. We want to match up to the minus 14, so we're going to have a minus 7 here. Now let's just check that that's going to work. 4x squared minus 7x plus 8x, so that's looking good, minus 14, so that's all very nice, and that gives me the solutions of x equals 7 over 4 or x equals negative 2. And we can see that negative 2 times 4 equals negative 8, and 7 over 4 times 4 equals 7, as required. Okay, so it's just a different way of thinking about quadratics and what it means to solve an equation. Now in part 2, what we're going to do is generalise that idea. So that was a merit question. Here comes the excellence part. Find the relationship between the solutions of this quadratic and the solutions of this quadratic. D, E and F are real numbers. So the only thing we can be going to use here is the quadratic formula. So we're just going to apply that to each equation and then see if we can see a link up. So first I'll do this one. So A is 1, B is E, and C is equal to DF. So my solutions are x equals, let's just write the formula out, negative b plus or minus b squared minus 4ac over 2a. We're going to do it for the other equation as well. We might start that off now. So for the second equation, for this one here, a is equal to d, b is equal to e, and c is equal to f. So we're going to do the quadratic formula on each of these. So here we get x equals negative e plus or minus the square root of e squared minus 4 times 1 times df divided by 2. Okay, so that's negative e plus or minus, cleaning it up, e squared minus 4 df divided by 2. Now over here we're going to get x equals negative e plus or minus, I'm going to run out of room on my tablet, e squared minus, and again 4ac is going to give me minus 4df. I can just squeeze that in, right? Hopefully you can see that okay. Divided by 2d. Right, now it's time to stop and have a look at where we've got to. On this side, we've got this solution. Over here, we've got this one. So let's see how they look. Well, they look nearly the same. This bit here is the same, this bit here is the same, but this has got a 2d and this has got a 2. So this one is equal to 1 over d times, no I can't fit it in, this is the solution to the first one. Sorry, that's very messy, but that's times 2. So what we found is that the solutions to this one are 1 over d times the solutions to the other. I'll call that equation 1. So this is equation 1 here. So the solutions to 2, this one, are 1 over d times the solutions to the 1. The other way to say that, of course, is that the solutions to this one over here are d times the solutions to that one. Okay, so another interesting question. Just make sure you've gone through it. All you're really doing there is using the quadratic formula with letter coefficients instead of numbers. Thank you for watching, and let me know if you've got any questions.